Hey guys, we're gonna try and attempt this new challenge on LeetCode, the power 1 power xn. So implement a power function xn which calculates x raised to the power n. And we have three examples. Example 1, 2 to the power 10, it gives us 1024, 1024. And as a reminder, if you don't know what power is a number timed in itself x time. So in that case, 2 to the power 10 is 2 times 2 times 2 times 2, 10 times. We have example 2, where it's 2.1 to the power 3, which is 2.1 times 2.1 times 2.1, so 3 times. And we have an example where the power is a negative number, and as you can see in explanation, it's basically the same as with a positive number. So explanation 2 to the power minus 2 is the same as 2 to the power 2, but you use whatever value you get to divide 1 by that number. So if we go and do a simple approach, it would be to iteratively multiply the number by itself. So we have one base case to think about, though, is that any number to the power 1, the value is 1. So what we can do here, we need to take this as a criteria. Let's wait and come back to it. Actually, yeah, let's do it. So so let's say if power equals 1, then we want to return 1. Actually, I believe as well if it's minus 1, it should be 1 as well. I guess we can check quickly and ask Chrome to tell us. So let's say 3, 2, let's bring a calculator. Let's bring up a calculator. Calculator. We can quickly, now there we go. We're going to stay, okay. Let's see. So 2, do you have a power function anywhere here? In the scientific. 2, how can we do this? So we do 2 to the power, let's say 3, expect to get 8. Correct. So, so if you do 8, let's say 8 to the power 1, expect to get 1. Oh, sorry, I was talking about, forget about what I just said. It's not the power 1, because the power 1 is a number itself. It's the power 0, where it gets the value and turn it to value 1. If the 8 power 0, I get 1, and whichever value I take, that is the power 0. I got 1. Okay, it was good that we checked. So if n is 0, then we would return 1. Then what I'm going to do is loop through all the numbers from 1 to n. So for 1 and stop just before n. So n index, and when we increment index first, what we would do here, increment the value. Let's take that value result. Equal to 0. Give the value of 0. No, actually, we're gonna give you the value of the original as it was with x. Then we return this value at some point. Let's put return here. So what we're going to do is multiply, we said, results, and it's results times x n times, and we return this value. But we also saw that if it's a negative value, if this n is negative, then we need to actually divide 1 by it. So our return value would be if n less than 0, then we will return 1 divided by results. Yes, and we just return results. So that's the simplest approach. And if we try and run this code, it should pass. Let's do one example. Just do one code. Submit this code. See what happens. And this code should pass. Actually, it will pass because when the number is negative, so we have an issue with minus 2. 2 to the power minus 2. So what's happening? It's a negative number. So we would do let me think about this one. 1 divided by result, why not? So 2 to the power 2. Oh, okay, that's the issue here. The issue being that n in that case is negative, and we should actually look increment all the way to the absolute value, and there's a function does this, which is adds the absolute value, and then later then we restore it by doing this check here. If we submit, we should get either a pass or an error. So okay, so what we see here is a time limit exceeded, which means that we passed many of the number of the tests. There's one usually when the input values are very big, where we exceed the time. So in that case, if we incrementally, as we're doing here, multiply 2 by 2 by 2 by 2 by 2 this number of times, which is a huge number, it will take forever. So one of the things that we can notice and how we could improve this code is that, say we wanted to, something's happening, what is this? Same that so let's keep 2 as our example. Or maybe we can, why not take 3 as an example. It'll be simple enough. Let's try. So if we say we had 3 to the power 6, 3 times 3 times 3 times 3 times 3 times 3, iteratively as we're doing it, going 3 times 3, 9 times 3, and so on and so forth. Which I believe was 27, but it can take forever. What we can notice, however, is that we're doing the same calculation a number of times. For example, 3 to the power 6, which is what we have here, is 3 to the power 3 times 3 to the power 3. It's also 3 to the power 2 times 3 to the power 2 times the power 2, and so on and so forth. So what we see is that we're doing the same calculation a number of times, and also we can divide our calculations into multiple sub-calculations. So let's see how we could do this. One of the very used method for dividing is divide and conquer, and we tend to divide a problem into two subproblems, two or more, but usually two subproblems, and divide this subproblem into two, another two, and so on and so forth, which means that we have a case for recursion. That's number one. So if we, let's take this example again. So 3 to the power 6. We could divide this into, so let's say 3 to the power 6. And we have a power sign here. Power, okay. 3 to the power 6 divided into 3 to the power 3 times 3 to the power 3. And we could keep, dividing this into more. For example, this could be 3 to the power 2 times 3 to the power 1 times 3 to the power. So the same values again. And so on and so forth. And the last one, which would be, I would just do this way so it's simpler for me. It could be 3 to the power 1 and 3 to the power 1, 3 to the power 1, and 6 times. If that makes sense. Actually, I could even indent it so it is clearer. Not sure what this declaring is all about. Let's say this way. This help understanding this. So how are we going to tackle this recursion? So to do recursion, let me comment out this function. I like to use a helper function that I will call, let's call it power rec or recursion, power. It should be a function, and what this function, I need to call it at some point, but let's continue. What this function will do, so we will take a number let's an n as well. I just don't want to confuse you with this, but a number, let's call it num, and a power, which is basically two parameters, just like our function at the top here. And what it's going to do, we need a base function. So if our power is 1, then we will return our num. And if it's not, then we would pass this, so we would divide the power. Let me think how we're going to do this. Yeah, so we could divide our power by 2. And let's see how we can do this. So we want to divide our power by 2, but we want an even number ideally. So we can keep dividing by 2. what I can do out of simplicity is check, so make sure that I'm always passing even number. Then we can try and fix this later, but let's assume that it's an even number. So what I can do, as in the power is an even number, I'm gonna call and return our recur of divided by 2 times itself. Return, we should return the value, so we keep things we get to itself, and I multiply this by this, and then I would return this power recur function with the parameters x and n. But as I mentioned earlier, we want to make sure that you could see as a make it the problem simpler. I want to make sure that my n is an even number. So what I can do is n, so let's call it new even n. So let even n equal if what I'm going to do is if x n modulus 2 equal 0, then we would return n, else we return n minus 1. And then that at some point I will need to, so let's not return this yet. This is the result. I will pass this even n, but then since I'm subtracting, if actually the n was not even, then I need to return that value. So what I will return will be res. So if I do, I'm going to do this simply. Even n, can do the same math, can we? So same bit of repetition, but for now we should do. So if it's even, then return res, return res times one more iteration, which is of x. So this should give us the output that we're expecting. I believe, so basically, is it even? If it's even, giving the value. Oh, there are the typo here. Actually, it's gonna work. So if it's even, then give me n, or give me n minus 1. If there's any errors anywhere, so if the power is 1, 2, 3, let's run this, see what happens. We pass the test case. Runtime error, num power. Another num. I don't like these type of errors when you cannot really tell what's happening. So it's saying that we have an infinite loop, I suppose, quantum error. Max call stack is exceeded. Let me think. So if we take the example, if we divide by okay. So we cannot just divide by 2, even though it was convenient. So the issue is in this case is that if I divide 6 by 2, I get 3. But then if I try to divide 3 by 2, then I get 1.5. So really, what I would need to do is we need 2 values. Let's val 1 equal so math dot floor, because I'm going to divide divided by 2. So if it's 3, I'll get 1.5, which is basically 1. And my second val, val 2, will become my power minus val 1. And what I'm going to pass here is val 1 and val 2, which I hope this will work. Let's see if you have any other errors. Atomic City. Seriously? That's our change. So whereas we have an issue. So num is of the issue is the power. So in reality, I guess we don't even really need this. We could just do power, because this was to make it convenient, but really it wasn't. So I don't think we need this. Even let's return our results. Just return. And pass n. Now that we have less code, what is the issue? So we have num power base condition or return n. So if I do example, my power will be 1. What's the issue here? So if that's base condition, return n. Then we have a big number that we divide by 2. In the case of, actually we can just do this one, which is 3 to the power 6 instead of the test case. 3 to the power 6. What we expect it to happen. So I pass x and n. I divide num and power, so I divide power by 1, which is not the case yet. I return this value. If not, what I will do is divide power by 2, which gives me 3, and then by 2 minus, which gives me 3. So I multiply 3 by 3. Okay. I guess probably got what my issue was. I'm not calling the same function, that's already a start. But why doesn't it tell me that? Okay, that will be for another episode. Let's see what I get here. The party fail. One time error, which is different error. Now I'm returning something with an equal. Really? When code taking longer. We pass, fail, pass, fail. We passed. Okay. It was long, but let's try and submit. Let's see what we get. No. We didn't divide by. I have an error as well in the case. Yeah, 2 to the power 2, and we forgot, which is what we forgot, which was we could have kept similar solution. So what we can do here is we'll make our power new power new power new n new n. That's why not? That's n, which become of n. And instead of n, we're going to use abs n. But then we need to remember that we need to divide the value. So if so if n is less than 0, then we would return 1 divided by this. Otherwise, we return exactly the value that we get back. That way. Finished. So you know this. Oh, wait. Okay, because I'm doing this one again, so we can do the test here. 2 minus 2. Confusing because it doesn't clear. Let's do 2 minus 2 and see what we get. Finished. Correct. Woo. Let's see if it's any faster, and if not, then we can continue. And even better, submit. I'm confused. So if my input is 0, I get 1. Yet, what are we taking? Method declaration. Oh, we're not. We're not. Okay. So number 1, which is that's what we were doing earlier, that we're not doing anymore. But let's do it. So n 0, and we should return 1. So it makes me think we get floating numbers for power. Will that work? Okay, I don't know. We can submit. Judging. Now we're going to exceed time, and if we are, we may need to use time exceeded. So we still exceed the time, but what now that you guys have been saying is that if you take the example of 333, we're calculating some times what we've done before. We're already recalculating it. So 3 times 3, 3 times 3 to the power 3, 3 to the power 3, I'm doing twice. So that's with a calculation. So what we can do is, so if it's a power that we've seen already, we can bring it to calculation. So let's say we get to the very bottom, get 3 here. So we get 3 to the power 1. Okay. So return 1, so that's easy. So let's say we get here 3 to the power 2, give us 3 to the power 1, and 3 to the power 1. But we already get 3 to the power 1, right? So what we can do is return straight away. So if instead of returning that value, we will first save it somewhere and then calculate it. So I like to use a map. So let's calc as a calculation that we've seen previously. Go new map, and what we're going to do is put the result of this value before we return to the map. So the map, and we're going to say calc dot set. We're going to set for the power, for value of that power. We're going to set this result in it. And really, we could just return calc dot get power, and before we could return earlier here. So if we have, if calc dot has, so if the value, we've seen the value before, has power, then we return calc dot get power. So let's check again the value in it. So if we run this now, we run it, I submit it. Then, okay, maybe I said if. It's time I say things, but I don't write them down. So if this, then that. No? Then put submit. Accepted. That was it. And now if we just see time complexity. Oh, okay. Never seen a curve like this, but it's 26. We be 26% of JavaScript submission, and we beat 88% of memory, which is great. So now let's maybe just recap. So we recap now what we done. So we tried to implement the solution iteratively, the so-called naive implementation. But we saw an issue with it where it would take forever, literally, at least in computer time, where it's too long. So we exceed time because we go to n number of iterations, which is this n value here. So we thought about it and we came up with a divide and conquer solution, where we would divide the solution number of times, and for divide and conquer, it's common to use recursion. I believe you can do it also with iteratively, but we use recursion, and with recursion, we were still exceeding the time. So we went into, we added a functionality that is called memoisation, which is, since we noticed that some of the calculation was done multiple times, we saved that value and we just returned that value. So for example, here 3 to the power 6 is 3 to the power 3 times 3 to the power 3. Why calculate it twice if you already calculated it once? So we save that value, and it's called memoization in this value, in this map, and we just output that value straight away if we've seen it before. If you want to learn more about it as well, you can look into